Welcome back, guys. Today is day 19 of this 30 days Leetcode challenge, and today's question is search in a rotated sorted array. So let's get started. We are given a sorted array in ascending order. So the array has been sorted in ascending order, but it is rotated at some pivot unknown to you beforehand. So some of the elements that are present at the end have been have been rotated and put at the start of the array. So as you can see, 4, 5, 6, 7 of this sorted array have been placed in front of the array. Now we are given a target value to search in this sorted and rotated array, and if the value is found, then we have to return the index. Otherwise, we have to return -1 if the value is not found in the array. We can assume that there are no duplicates in the array. And our solution is expected to run in log n time. So this is let's say this is the array that is given to us, and we have to find the index of 0. So in this case, you can see that the index of 0 will be 4. So let's get started. So in this case, whenever you are given a sorted array, it becomes kind of obvious to use binary search. So that is what we are going to do. But since the array is not exactly sorted, so one approach is to either find a pivot element where the rotation actually was done. So if we find the index of the smallest element, then we can assume that all the elements to the right will be sorted, and all the elements to the left will also be sorted, and we can do a binary search in that case. The other approach that I'm going to use is directly try it out for a given value, and check if we find it either in the left array or the right array. So if we find that our sub array is already sorted, then we can directly perform a binary search. Otherwise, we'll just recursively call the given function by decreasing the range from to the middle of the array. So, uh, so what I'm going to do is write a new search function, which will also take in the range, something like 0 to whatever is the length of the array -1. This will be the last index of the array, and this will return me the index where the target is found. So let me write this function, and this will take in the start and the end index. And here the base condition that we'll use is if the start became more than the end, then it simply means that we did not find the target. The other thing that we'll be using is checking whether the array is sorted from start to end. So the the function that I'm going to use is less, which will check whether whether the element at the start is less than the element at the end. If this is the case, then array is sorted. Then we can just do a binary search for this given range and the given target. So we'll just pass in the start and the end. Now this will be done in login time, but if the range given to us is not the array is not sorted in the range that is given to us, then in that case we'll have to find the mid element. So the index for the mid element will be start plus end minus start by 2. The reason I'm doing this and not just directly doing start plus end by 2 is simply to prevent overflow. So this will help if start plus end ends up overflowing, uh, then the mid element, the index will be that will be returned will be wrong. So this prevents the overflow part. Now if I found the mid element, and if I find the target to be present at the mid element, at the mid index, then I can just return the mid index. Uh, the other Else what we should be doing is first searching in the left array for using the usual search function, basically recursively call the self function, but with a decreased range. So will it will be mid minus 1, and if we found that the index returned from this is not equal to minus 1, then then our target is found at the left index. Else we'll just search it in the right subarray for the target, and the right subarray will start from mid plus 1 and go up to the end. Now we'll write the binary search function because it is required here. So it is supposed to return the index, and sorry, so I'll write the binary search function, which takes in the array and the target and start index and then end index, and the same way as we did earlier, what I'll do is add a base case. If the start became more than the end, then the binary search won't work, and then we did not find the target, and we just return minus 1. For the rest of the case, we'll just find the mid index the same way that we did earlier, as well, and I'll do the same check. So if my target is equal to the element that is present at the mid index, I can just return the mid element. Else if my target is if the element that I'm supposed to search is actually less than the element that is present at the mid index, then we have to search it in the left sub array basically. So we'll do a binary search in the left sub array. Start up to mid minus 1. Now you have to ensure that you are always decreasing the range, because we have added a check for greater than, and if the start and end both become equal, then in that case the mid element will not change. So you'll end up with a stack overflow exception if your range is not decreasing every time. So you have to ensure that during recursion, and this will be for the right subarray. Okay, and there is one more function we have to implement, which is the less function. So this will be pretty easy. So this is supposed to return a boolean, and it takes an integer array and an index I and index j, and we just have to return if the element at index I is less than the element at index j. So let's run this and check if this works. We got a compiler error. Oh, we wrote a start somewhere. Yeah, here. So this is running. Yeah, so our answer matches the expected. Now just to ensure that we are not breaking any of the range, so I'll pass in another array that contains a single element, let's say 1, and I'll search for 0 in this case. So the expected answer would be minus 1 because 0 is not present in the array, and yeah, so it's working. So let's submit the solution. Check. Okay. The internet is pretty slow. Let's see. Our solution got accepted fast, so it must be better than most of the solutions. Yeah, so our solution performed. Performed better than 100% of these submissions. So yeah, thank you, and If you like this video, give it a thumbs up, and do subscribe to my channel if you want to be notified about the 20th problem. So thank you.